Okay, this look is generally pretty good. I think I agree with these colors. Oh man, I forgot the freaking color scheme I used. Oh well, I guess I have the magenta and I have the red. Oh wait, I don't have the red. Well, I know where to get the red, whatever. But anyway, this is pretty good. I feel like the terminal... Nah, the terminal's fine. It really needs a way to resize this. But I feel like that can wait. What I really need to focus on, I think, is anti-aliasing these shaders. And I should maybe set some stuff up for that lesson as well. Yeah. Although this will get a little tricky since the web version and the local version don't use the exact same shaders. Let me check this. Go to shader source. I don't list any version string, but I think all WebGL is like OpenGL ES2. Whatever that means. Maybe I just Google WebGL version. WebGL 1. WebGL GLSL ES1. Okay. So it could be the case that if I modify the shaders here, not there. And just like one of these. I wish this showed the full name. I messed up my settings. But this one's for the strokes. This looks like it's using OpenGL 3. Maybe all I have to do is if I go here, go to like shape test. I'll take out the opacity on this then. If I run that. Okay, so that's a circle. Actually, don't even need the animations. Let's just do this. I'll scale it up. And I don't see it anymore. And that's way too big. Oh, I have to add it. Great, so this looks good. Definitely needs some anti-aliasing if I can figure that out. Let me see what happens if I change this version to like 300. Already fails. Well, it tells you the versions that are supported here. It doesn't even have version 1. Oh, it does have 100 ES. GLSL ES1. Man, it's so old. I guess nobody uses these shaders other than me, so I guess it's fine to bring the version back. 100 ES. That's bound to be a huge pain. I switch this to 100 ES. There's no way this will work. Version 100. Yeah, no precision specified. So what I'll probably have to do... Actually, I think the way to do this will probably be to add anti-aliasing to the web shaders. And then following that, there'll be a reason to port those over to the local version, and it'll look a lot better. And after that happens, hopefully I can use the exact same shaders from both of them. What happens if I increase the stroke? Bring that up to 8 or something? It doesn't look terrible. I guess especially when the screen is larger. But it would look a little nicer if I did anti-alias this, I think. Like here, you can see some of those artifacts from aliasing. First things first. Let me go ahead and add this stuff. Here, there's not really any differences. But I just want to get a scene that makes it really easy to showcase the aliasing. So I might as well just take this one, actually. Oh, wait. Example 1. Part of me wants to give these better names than example 1. And the other part of me knows that really I should just implement a way to switch between scenes. That's what should happen. But, you know, maybe one day. Well, let's put this down. And to call that example. And that one's 8, this one's 9. I'll export that one. No such thing as interactive embed. So let's just set up and just put the circle here. It should be enough. Great. I actually don't think I had to redo that. Hey, Daryl Golden, what's going on? And there's no circle here. Why did that happen? Oh, it needs a draw. That's something else I have to do. I need to give this a default. I have to give the scene a default class that does have draw, so that I don't have to give an empty one like this. But anyway. Okay, great. So this has the aliasing effects too. Set that to 8 or so. Try that again. Yeah, now for the stroke, I think before doing aliasing, there's something else I need to do. Because I noticed in one of the earlier examples, the example with the matrix transformation, that updating the model matrix would stretch the lines in a way that I don't want it to. Where is it? It's one with the mouse drag. I go to this one. if I stretch this really far, I can see that this line is getting thicker. And I don't think that would ever be something desirable. Also, it's possible to... Oh, wait. I think something is up with the translation from JavaScript space to Python space as well. But I'm pretty sure it doesn't make sense for this to expand the lines themselves. And I think I know the reason for that too. So this is the shader for the strokes, I think. Yeah, this is the shader for the strokes. It's probably the most complicated shader. I might end up just using a different approach with it. But what this is doing is computing a tile, projecting the curve onto that tile, shrinking it so that it's a strict bounding box, expanding it so that it can accommodate the line's thickness, and then it's going to pass that tile with the curve projected onto it to the vertex shader, and that's how it draws it. I think the problem here, is that I'm expanding the tile after projecting onto it. And I think that's incorrect. I think. Because I'm going to do this distance conversion. And I do this distance conversion as if the curve itself was not transformed. So maybe what needs to happen is if I transform this tile, which I actually need to, I should also transform the points of the Bezier curve, which are... It's these, UV curve, 0, 1, and 2. What's the UV point? Convert to UV. Tile X unit, tile Y unit, and the tile point. I know that the X unit and the Y unit define the directions that the tile, well, basically the directions that specify the tile in 3D space. I'm not totally sure what tile point is. Position at 0, position at 1. Like, what is position even? I remember I had to rename this. Is this a tile coordinate? I think it is. I think I did look at this in the Python version. Strokes with width. Okay, so I have the curve that I pass in and tile coordinates. Then I pass in 0, 0, 0, 1, and 1, 1, and I also pass in 0, 0, 1, 0, 1, 1. And that makes sense because those basically trace out a triangle. It's like the upper right corner and then the lower left corner, something like that. Okay. So that's what these are. And that's what's used to get these tile points. And these do in fact have to be transformed. Now I also need to transform the UV curve, I think. I think. I wonder how I even got these UV curves points. It must have been from projecting them onto the tile. Must have. Let's see that UV curve 0. Yes, I'm converting those to UV coordinates here. Take that. The dimensions of the tile and that curve, and I project that onto them. So, how can I transform the UV coordinates? Maybe it's as simple as transforming these before I project it. Would that work? Tile X unit, tile Y unit. Oh, not necessarily, because the X unit and the Y unit themselves are going to be transformed. And so when I project these, if I transform these and I project these transformed points into these non-transformed points, that would probably do something wrong. Tile X unit. Maybe I can just transform these? But these points are two-dimensional. In fact, 2s. And the transformation matrix takes 4-dimensional points. I guess it's as simple as, it might be as simple as setting the Z coordinate to 0. The Z row and the Z column to basically zeros. Guess I'll try doing that here. Curve points. If I do that, then hopefully I can get it to where expanding this wouldn't expand the line. Is that true? I almost feel like the width needs to be modified. Would that be all? I'm actually confusing myself now. Well, it's actually just a confusing problem. Basically taking a tile and taking a point on that tile and stretching that tile out. Meanwhile, and stretching it out doesn't have any adverse effect, I don't think. What I should do no, it will have some adverse effect. Because I basically have this tile like this. I have this tile, and it has this line projected onto it. It should be thicker than that. It has this line projected onto it. And then I'm stretching the tile like in both these directions. And if I do that, then if this line is projected directly into the middle, the width calculation shouldn't change. I wonder if I just have to transform the width, the V thickness. Current curve 0. Expand the tile according to... Okay, so this is expanding the tile. So that makes sense. I might need to expand the thickness though. Because if it's stretched, that thickness should be brought down. But then I'll have to separate the X stretching and the Y stretching, and I don't know if it's possible with something one-dimensional like thickness. For now, I think it'll come down to transforming the points. So let me go back to trying that. Okay, so all I did was take the model view matrix and the projection matrix. Now, this is looking for a vec 4. So I know I can't use this directly. I'm gonna have to convert these into vec 4s. So I can just take UV curve 0, for example. This is 2-dimensional. I think I'll have to take a matrix. I think I need a 0. And then a 1 like this. This is indicating that transformations in the Z direction won't have any effect, but translations will. So I can take this, and then it'll be in homogeneous coordinates. Actually, I don't even know if I want the translation to do anything. Maybe I just want this. So it only gets stretched. Then I can take this. Hopefully there's a way to take the first 2 entries. Should be a vector operation. Vec 3 of A. Okay. I can see ways to reduce. Oh, I just need to do, I think, this. Vec 2. I think that'll take the first 2 entries. So maybe that'll transform it. Let me see if that at least runs, because I'm not entirely sure it will. Nope, something I didn't like about it. Vec 4, line 118, Vec 4 syntax error. Wait, what? Zero 118, Vec 4, syntax error. And 118 must mean this, I think. Computing the curve's bounding box? Oh, I didn't put a semicolon there. Maybe that's what it was. Okay, so it didn't crash, which is what I was looking for. It does look like the lines are still straight. Well, it's hard to tell when I'm only transforming one of them. Anyways, let me transform the rest of these. Okay. So the translations, and there won't be any Z scaling. Okay. But this will hopefully take care of any of the stretching that would occur from the model view and projection matrices. Hopefully. And that didn't work. Interesting effect I get, I guess. Okay, so that's not the solution. It might end up being that I do have to compute thickness in like 2 dimensions, which will be super annoying. And part of the reason I think that is because if I have a curve, if I have a curve just like this or something, no, not a line, but I have some curve like this, and it has some thickness, and then I stretch it only in the X direction, like that, then the Y thickness won't be affected. The result will be a curve like, it'll be stretched, which I want it to be, but then the X thickness would be way more than the Y thickness. It would look something like that. That. I think, I'm pretty sure. Let me just test that. Darn. Points. Actually, I'll make this left. Then I'll have up and then right. Get some width, like so, and just add this. Okay, so that looks fine. If I stretch this and only the, actually I'll make this a little thicker even. Great. If I stretch this in the X direction with a model matrix, GL dot, oh, I can't even do that. I guess that's why I never saw this problem. I can't do it with a utility. Like 3000. I think the rest of this will just be the identity. Basically, this will basically scale it in the X direction. So if I run that, I think I'm seeing that problem. Is it stretching more in the X direction? I guess it has to be. Maybe if I actually made this skinnier, it would appear more. It's actually pretty hard to tell. Maybe make this 2 times up. Okay, and then it's more noticeable. Then I can do 2 times down plus this side. And here 2 times down. Yeah. Yeah, it's definitely stretching more in the X direction than the Y direction. How would I even solve that? I guess I could exaggerate this even more. Is 6 times up even on the screen? I think it doesn't matter. It might actually end up being, I have to, for each point. This could be tricky. Because that thickness is one-dimensional. Let me see how I'm computing that distance right now. Sine Bezier. So here, I'm just taking one-dimensional distance and looking at a threshold, basically. Is that distance less than the thickness I want? The problem is that these dimensions can be morphed. Maybe all I have to do is transform the points before I do anything. Shouldn't that be fine? And by that I mean... Was it trying to do that? I mean, look at the vertex shader. So I have these, I have the thickness multiplier, the color, a normal, and the degree. Wait, where do I use the manum normal? Oh, it's here. Unit normal is computed normal. Wait, where do I use the manum normal? Do I use it at all? Oh, here. Maybe all I have to do is... wait, current curve, that's a vec3. I might want to transform those points right here, and maybe that's it. Maybe it's just like transform the points. Curve. And that might be easier than attempting to transform the UV coordinates because the current curve is already 3-dimensional. Each point is 3-dimensional, and so transforming it with the model view and projection matrices shouldn't be hard. It's worth a try, let's see. And then I guess I won't transform the tile coordinates. So I'll say... I guess I can't overwrite these variables, which is annoying. Vec3 and 3 transformed current curve. Should be able to do that. Now, running shaders is annoying because you can't really test them without just rerunning. So I'm going to do this every time I change a line, basically. You want the vector or transformed current curve at 0. It's going to be this. Projection matrix times model view matrix times. This will be current curve 0. I'll do this for the 1 and for the 2. So now I have the transformed coordinates. For this, rerun it. And that makes sense, actually. Just have to wrap this in vec3. I guess I have to transform the manum unit normal too. I'll get to that later. Okay, so that still runs. I guess I could do it here. It's a vec3 anyway. Okay, so now I have all of those. And now what I think I need to do is just not transform anything else. Let me test one more time that this is still working. And it's not. It's a vec3. Okay. And now let's just not use anything untransformed. So use the transformed version of that. And anywhere is a current curve, use the transformed one. Project the curve onto the tile. Yeah, that should be the same. That should be the same. I think this should be the same. And now I have to be careful. Is this the GL position? I think I don't transform this. I just give the vec4. Yeah. Hopefully. Wait, wasn't trying to do that. Okay. And now I don't see anything, so that's great. Do I still want to... I think I do still want to... Pretty sure that's not correct. Not correct. Okay. Here's what I'm going to try doing now. Let's color that tile. Don't just discard this. And just make that red. Main returning void. So I have to say frag color equals that. Still don't see it. Okay. Let's bring this back. Now I just have the transformed points. Okay. Let me just go through these one by one. What is this doing? It has the tile X unit. And I guess it's computing the tile Y unit. Simple enough. Okay. So we try using the transformed current curve here. This should be totally the same. I think it is. If I use the transformed curve here, I think that'll be the same. Okay. No, that's fine. So I'm dotting the Y unit with this difference. Current curve at 1 minus current curve at 0. Okay, that should be fine. So those should be in the same direction. This should be the same computation. Okay. Projecting the curve onto the tile. Does this make sense? And I think it does still. As opposed to projecting the regular points onto the tile, I'll be projecting the transformed versions onto the tile. Yeah, I think that's... Actually, how would shearing work with this at all? Would it work? It might not. These are going to be like some kind of janky shaders. Because I can get the X unit and get the Y unit. Yeah. Well, here. I think this should be fine at least. And compute the curves bounding box. Okay, so... Okay, so that... Wait, what in the world? Did something. That is a long tile. I can't even fit it on the screen. It does have part of the curve. But I think this would happen because I'm transforming the tile when the tile has already been transformed to accommodate the longer shape. So if I use this transformed point, wait, tile translation? The unit normal dotted with the transformed current curve at 0. Oh wait, I'm taking this dotted with a unit normal. Then translating it. Why would this... Oh, this is the... This star is pointwise multiplication. But what is this? The current curve at 0 dotted with a unit normal. Shouldn't that just be 0? I guess not necessarily. So wait, the bounding box minimum and maximum. And this seems to be doing something wrong. Tile translation. Guess I have to figure out what this is. So I'm converting this, the transformed curve, to UV coordinates. That I think is okay. Then I'm computing the bounding box from that. Maybe I should look at this. Guess it's just a generic function for this. The UV bounding box. X unit, tile Y unit. These X and Y units were computed according to the transformed points. Like here and here. Wait, where's the unit normal? Computed normal. Wait, where did I set that? Okay, I guess I got it from here, so that's safe. Something about projecting onto the tile. Why would that have a problem, though? So one thing, let me at this point untransform the tile, since it shouldn't have to be transformed. And the tile X vec and tile Y vec are fine. Or the tile X unit and tile Y unit are fine. The X vec and Y vec might have a problem. Since it's using the bounding box. Anyway, I'll see what this does. It's from untransforming the tile. And now the entire screen is red. Darn. I guess I can't do that right now. And make sure this is at least where it was before. Where I can at least see this curve. It does look like it's fixing the distortion in only one dimension. But I have to find a way to project this correctly. Maybe if I didn't do the bounding box thing at all. If I don't do the bounding box, and I don't expand it. Tile origin Oh man, so much of this came from the bounding box. Maybe I could just multiply these by some arbitrary number. Like I could use... this with a transformed current curve at 0. And both of these I just multiply by some large enough value. And there's a chance this will work. Nope, some of this undeclared. Does have to be unit? Don't have to be unit. In width. So what happens when it isn't used? Does this not use the thickness? Distance. Here the thickness is used. Did I set the V thickness in there somewhere? Yeah, I did. Let me just bring that back. And the same thing doesn't appear. Oh, I guess it appears somewhere. Way over there. I worry I might have to restart a lot of this shader to do this quote-unquote properly. I don't think that should have to happen. Okay, let me go back some more. Okay. So here's where it is right now. This is before trying to compute the bounding box. And what I want to get out of is basically transforming this tile point. I think that's what I needed to do. UV curve 0, UV curve 1, UV curve 2. Part of this problem might be is a Bezier curve under an affine transformation even necessarily a Bezier curve anymore? I guess if it's sheared, then definitely not. But if that's the case, there might not be a good solution to this. So this is basically just dotting the x unit and the y unit with the points on the current curve. I wonder what the difference even is. Tile X unit and tile Y unit. What's the difference? What should be happening is that in one case... Actually, I have to draw this out to understand it better. So let me see. In one case I have this tile and there's this curve drawn on it. And it's basically taking this curve is in 3D, but I can give it UV coordinates by defining the coordinate system. U is like this, V is like this, and then I can give it UV coordinates. So basically, if there's a point here, that becomes 0, 0. The point here will become 1, 0, so on. So I can do that. And all that depends on is the U and V vectors. Or I could transform this tile, or not the tile, but transform the points beforehand. So this is the transformed curve. And now use this same U and V system and transform it this way. It should do the same thing, I think. This would still be 0, 0. This would still be 1, 0. The only way I see this mattering is if the curve was sheared, for example, and was sheared really badly, then the tile's dimensions might not be right for projecting it. Like, that could be points that are sheared outside of the tile. But other than that, don't see why this would be different. But it is different. Actually, no, this makes sense. I think, because just because the transformed curve is, transformed, in this case stretched in the x direction, the UV coordinates will also be stretched in the x direction. Let me try to do this bounding box thing. Which I guess requires the origin, the x vector, and the y vector. Let me try saying this. I can just say tile origin for now equals the transformed current curve at 0. And the x vec and y vec are just the x unit and the y unit. And I'll just make them big enough. Something like that. And here it gets expanded, which I don't know if that needs to happen. Oh wait, that could be a problem. Because this is expecting it to be the exact bounding box of the shape. That's kind of a problem. Darn. Projecting the curve onto the tile. I think I'm gonna do this. And then just render the tile or something. Let me try doing that. Or, maybe a cleaner way to do this. Just come up with a transformed UV curve. Yeah, just put transformed. Although I feel like these should be the exact same. Whatever. See if it lets me do that. And it does. Okay, so I have the UV curve using the transformed coordinates. So I'm gonna have to compute this bounding box somehow. And then expand it. Where did this transformation happen? At the beginning, that's good. And the UV bounding box, and I do B box Bezier of these three. Okay. And tile translation. I have to figure out what in the world this is. I'm just gonna basically do a transformed equivalent of this. Okay, so here's the UV bounding box. I'm gonna use the transformed version of these. See if I'm allowed to do that. Maybe I'm not. Okay. Okay, this should do something similar. Tile translation. How is this even used? Okay, so I'm taking the unit normal, which is pointing in the normal direction from the tile. Then this is some sort of projection. It has to be. It absolutely has to be. And I think that makes sense, actually. I think I see what this is doing. The unit normal and the current curve at 0. Dot product of those. And then element-wise multiply by the... Okay, hold on. Whoa. The cord for this thing is placed so inconveniently. Okay. This is saying, and the origin is like here or something, and there's a plane, and this curve exists in 3D space somewhere. Now, I used this direction and this direction, just from the curve's control points, to map out a plane that contains this curve. However, this plane is only determined in terms of vectors. It needs an absolute position to place it somewhere in space, and so that's why it needs basically to know this vector from the origin. So I'm taking the unit normal from this plane, the unit normal, dotting that with this vector. And that's going to give me some offset, the offset from here to the plane such that this is like 90 degrees. This is curve at 0 dotted with the unit normal. I think you're following me. Oh shit. Darn. Is that any better? I actually don't know when you said that, so it might have been too quiet for a while now. But hopefully that's a little better. I need a better way to like work on my sound quality since I can't really hear what I sound like to the stream. Okay. This is curve at 0, this vector, dotted with the normal vector off the plane. And then, why would I multiply the unit normal? Oh, this is a scalar. This is like, yeah, and that's a scalar. So when I dot this, I get the length of this. So this length is that dot product. Then I multiply this by the normal vector. So that's what that is. Okay. Is it better now? Hopefully. Thanks for telling me. So that's what that is. And that could change with the model matrix, but I don't think it would change with the model matrix that's only scaling in the x direction. Anyway, I'll just bring this down. Oh wait, unit normal. Do I have a transform? I have a transformed Manum unit normal. But the regular unit normal, the computed unit normal, is computed using the transformed curve. So this should be the same. And still, I'll do that. Bounding box min, max, and vec. I'll just call this transformed whatever. So that tile translation, which should be the same between the transformed and non-transformed versions. Wait, what? Oh. So then I get the minimum and the maximum from the XY point and the ZW point. Which I guess this is just, wait. No, this is transforming this from UV coordinates back to three-dimensional, like Cartesian or whatever points. So tile translation, I guess this will have to be transformed. Tile translation, and this will have to be transformed. Bounding box min minus bounding box max. These will have to be transformed. Hopefully none of that broke anything. And it didn't. So in the origin, xvec and yvec, these would actually be different if the points were transformed beforehand. These would be different. Tile origin. I guess I'll just put transformed for all these. Top xvec. I don't know if the unit will be changed. Well, it is actually possible. But I don't think it's possible with a model matrix that only scales in one direction. Oh wait. Yeah, so that's not transformed. That's fine, that's fine. Bounding box vec. Yeah, these will be transformed. Tile X unit and tile Y unit. Okay. Transformed bounding box min. Okay. So it's expanding this, and I won't bother with the expansion right now. I just want to see if I can use a transformed version of the tile point, the GL position, and I guess the UV point. Okay, so put transformed here. Actually I should make sure that doesn't break anything. Great. Okay, tile origin, that should be transformed. Tile coordinate at 0, that shouldn't have to be transformed. But this should, and this should. This should just be that. And this, the UV point. Tile X unit, tile Y unit. Those should be the same. This should be transformed. Okay, I'll make sure this is working one more time. Then just try to render transformed version of the tile. And I won't try to expand right now. Actually, I should do one thing at a time. So now expanding. I'll use the regular points. Oh, just the oh wait. I just need the width. That should be fine. Weird. That doesn't look quite how I expected it. So here I'm not oh wait. No, yeah, this does make sense, I think. I think this does make sense. Okay, so transform tile point, then I'll set the GL position like this, the UV point like that. I guess the UV point is a varying, yeah. Okay, so I'll see if I can even see the transformed tile. And I can't, why? Where is it? Well, let me just sanity check this. If I make this the identity, even if it's the identity, that's annoying. So it looks like before I even want to mess with doing this with a transformation matrix that does anything, I have to get this to try to work with a transformation matrix that doesn't do anything. Just from transforming the points at the start. I guess at the point that this is transformed, they're in clip space. Does that matter? Because in clip space, the Z coordinate doesn't do anything. I don't think that should matter. Okay, but I'm gonna have to undo a lot of this. Okay, so here's basically where it was before. Oh, that's not where it was before. Oh, yeah, it is. Because now I'm not transforming it. Yeah, so this is what I was doing before. And this still has the problem that if I do stretch it in one direction, it'll get really thick in only one direction. Which is annoying. Okay, I'm going to try, I guess, rewriting these. And then doing this from the start. But if I do that, I'm gonna want to have a better approach to make sure I don't reproduce this mistake. I think this is being caused by the tile being transformed, but the points not being transformed on the tile. I think that's why. But, the points aren't just passed to the fragment shader, the UV points are. And I guess that because of that's causing the stretching. It's as if I computed it with a normal tile and then stretched the tile. But really I want to stretch the points along with them. Where are the UV points calculated? For the X unit, the Y unit, and the tile point. Nah, this is already pretty detailed. I knew having a complicated shader like this would come back to bite me. I wonder if it's even worth doing this. instead of just switching to a version of a stroke shader that is adapted from a bunch of straight lines, which would be a lot more straightforward. That might be the easier thing to do. I guess I just want to try. Is it worth it? If I'm going to switch these shaders anyway. Eventually. I don't know if I'll do that anytime soon, unfortunately. I guess I could switch to trying to do that instead of like working on something else. So much of this I don't think should even be super difficult. Okay, I'm gonna try rewriting part of this shader. Yeah. And if I were to do that, what would I even want it to do? I guess I could compute. Well, no, if I were to do that, I might as well change this one, I think. Because all I'm going to do is transform these points beforehand. Create a tile around those transformed points. And then render that tile. Am I able to do that at least? Because that would basically just be... Well, I guess it wouldn't be this exactly. It'd be this dot... Oh, wait. Current curve at 0 equals... Okay, this is kind of annoying. I have to do a homogeneous version. Okay, so here it's homogeneous. That needs to be vec4. Make sure that doesn't break anything. And then the transformed. So transformed current curve at 0 equals homogeneous current curve at 0 dot XYZ divided by this dot W. And that's how I would transform it. Okay. So then am I able to compute the bounding box around this? X tile vec, X, Y vec. And here I'm computing the bounding box. Let's not worry about projecting the curve right now. I'm going to try to just get the bounding box in a way that makes sense. Convert from UV. The tile X unit and the tile Y. Okay, try to make these transformed. And this. Unit normal equals computed normal. Okay. So let's see if that even makes like... Okay, so the tile still appears. That's great. That means the X unit and the Y unit are computed using the transformed coordinates. The tile origin isn't. I think I'm just going to say the tile origin equals the 0th point. Let's see how badly that messes things up. Not at all, I guess. Bounding box vec. The X vector and the Y vector. How could I figure this out? The X vector and the Y vector. I basically just need the tile unit times this distance and that distance. Which I don't think would be so hard. I'm gonna say tile X vec equals, I mean, I could say literally just current curve 2 minus this at 0 for the Y vector. For the Y vector, I'd have to like get this distance. So I can take that vector, or like, I guess it'd be up here. So this vector, and then dot it with the Y unit. Okay. This is 1 minus 0. Then dot that. The tile Y unit. Okay, so that's a scalar. Then multiply that by the tile Y unit. Okay, then that can be the origin X vec and Y vec. Okay, this... Now it's transformed twice, so it should do something kind of weird. Although I didn't expect it to do that. Well, that is going into the Z direction in some strange way. However, if I don't transform this, and it still does something strange. It's so close to not doing something strange too. Okay, but I don't think this is necessarily worth fixing right now. Or maybe ever. And the reason for that is I'm probably going to end up just linearizing all of the lines. I think. That's gonna switch a lot of the stuff I'm doing hardcore to line shaders. Which are kind of unpleasant to work with. I wasn't trying to go there. Kind of unpleasant to work with, but I guess I've gotta do it. But in that case, I don't know if I want to work on that like right now. Maybe I should try just adding a feature to this. Like being able to switch between different files would be neat. Or adding the default functions for mouse movement. So that it doesn't do this mouse move. It's not a function. I should do that. Okay. Well, that was annoying. So here's draw. And there's setup. Should I call it... Should I call this on whatever? Or just mouse down, mouse drag? I guess having the on prefix would make it a little clearer. I wonder what the naming convention is inside Manum already. So if I go to like... I think this is already in scene actually. It's called on mouse motion, on mouse scroll. It's actually kind of annoying that those are taken already. Point and D point. Because I don't think you can get a D point in WebGL. On mouse motion, on mouse scroll. So it must be on mouse drag. Although on mouse down and on mouse up. Maybe all it needs is mouse down. That definitely needs on mouse up. Because it's basically taken straight from JavaScript events. Mouse down, mouse move, mouse up. Here it's called mouse motion. And I don't know what it is for scrolling. I just have on mouse down. X and Y, and this can pass. And then I can do on scroll. Or not scroll, but up. Self XY, drag down. Okay, I want to make sure these aren't duplicated. Down isn't. Move isn't. Up definitely isn't. Okay. So then I want to edit those seams. Have on. Oh, I guess I have drag. And like, I don't know if drag is something that makes sense within the context of JavaScript. Like, kind of have to do drag yourself from like down and move. So I think I should probably just get rid of mouse drag. Well, at least not try to call it from JavaScript. So on mouse move, I'll just call mouse move. Mouse down, mouse move. And I need the on. So to do drag logic, you would, in the mouse down callback, you would add something to like your dragged or whatever. In the mouse up callback, you would remove that. And in the mouse move, you would check to see if your mouse is down. So that's how you have to do that. Now, would it get annoying always having to do that for drag logic? I guess it's the only way, that's how it has to be. Because JavaScript can't know if you're dragging or not. It's not a JavaScript concept. Okay, down, move, up, great. Now the on mouse down, on mouse drag, on mouse up. I think that's mouse underscore something. Or def mouse underscore. Okay, there are a few places with mouse drag. Let me recompile this really quickly. Okay, if I rerun this, I'm certain that the dragging won't work anymore. No, it still has this on mouse move error. Why? Before I call render, I guess Messin doesn't exist yet. Is it null? Yeah, it's null. So maybe I should only add this listener after the first time I rendered? Guess that would make sense. Well, but I only want to do it once. Maybe just say if random scene is null, just return. That's probably fine. So I can do it even shorter than that. Okay, rerun that. Now that error doesn't occur, if I do this, the error still doesn't occur. Mouse down is not defined. Okay. Yeah, that shouldn't be there. Now what this is gonna have to do, on mouse drag, it's gonna need to have on mouse move. Seems to have F on mouse move. Just gonna basically check, see if it's dragging anything. So if that is not none, they can call self on mouse drag. Okay. And I messed up some syntax. Yeah. Okay, so that's back to doing what it was doing before. Great. Okay, that's fine. What else would I want to do here? I think the next big thing I have to do is focus really hard on anti-aliasing those shaders. Wait, let me switch the example. And being able to switch the examples, of course. Because I would like to get it to where you can link to a big screen that just shows some example. But especially if I enlarge the renderer like more than this. Actually, when it's zoomed in kind of a lot, I guess the anti-aliasing gets better. But I think I want to do it right the first time, or like do it right within the shader. I wonder if maybe I could just add a new render pass. I've heard of... Vue.js has fast approximate anti-aliasing. Let's see what there is to learn about that. I'm not sure what this is supposed to be showing me. This is rotating very slowly. Let me 10x that. So I know these are using two different types of anti-aliasing. I can't even tell which one is better, really. I guess the one on the left, slightly. SMAA is also an option. FXA example makes you think it does a better job than it really does. The default anti-aliasing technique of WebGL is multi-sample. Fast approximate anti-aliasing uses a totally different approach that explains the different results. Would it be possible to use multi-sample anti-aliasing as a processing path? This one says fast approximate anti-aliasing and what is SM? Don't know what SMAA is. They're quite similar from the AA quality and performance. One is blurry and the other one loses some edges. I don't really want to hit that performance drop, so I'll try to do it within the shaders. But that's going to require some in-depth looking. Probably rewriting the line shaders, to be honest. Which is going to be very annoying. I don't know if I want to do that before I just get it to where you can select like a class name and stuff. I think that'd probably be more useful. So maybe I should just add a drop down or something here so you can so you can select a class. So here I had a button to refresh the class names. Maybe I'll just do something like that. I just do this.run Python. I wonder. So this should have a reference to the Messin. Oh, this must have used inspect. Something like that. And use that to get what? Classes? Example OpenGL renderer. So it runs the code. It's gonna have to run some inspect or something on the code. Maybe they should just have a text box, actually. Let me see if the regular Python code has a way to like check what classes are within a scene. So it has this file, I guess. Scene classes from file. I think that's actually exactly what I want. Scene classes from file. It's going to create a module from that file and then do that. Let's get module do. And this can take it from standard in, although I don't. Trying to access standard in from Python or from WebAssembly is bound to be pretty annoying. I remember trying to interface with this and it being terrible. I guess what I want is another function called scene classes from code. And then this will just get a module the same way. And then classes from module. I guess I'll have the same arguments. And then this is going to return scene classes from module of that module. Oh, and these. This is going to need get module of like code or something. Guess it just needs to do this. It doesn't have to do all this logging and stuff. Wait, where to get that module? Like this. And then it can go straight to scene classes from module. Okay, so let's compile that in. And then hopefully I can call scene classes from code on the code that the user puts in and use that to get back a list of the names of the scene classes. So refresh that, then wait, scene classes from code and module ops? What do I have to... module ops. Man, I'm utils module ops. Okay. Maybe I can just, here. I'm gonna need another button, I guess. What happens when I render? gosh. Okay, there it is. I'll just hit this restart loop. Okay, so I'm gonna add in another button, I guess. So there's one button. Call this one refresh. Great, that's fine. And this one, when I refresh, I'm pretty much gonna want to call module from code. Or refresh. Classes, I guess. And I want to do pyadie.run Python. Oh no, how would I run this? I'll have to get a reference to the manum object. And get value, and then I do pyadie.run Python code. Do I need to do that? I might just say classes equals I have to get a reference to manum. I have to do like manum equals pyadie.run Python manum. So if I do manum, manum utils classes from code. Was it scene classes from code? Oh, it's module ops. Scene classes from code. So that is a function that's available. Maybe I should just keep the reference to manum. Maybe that manum equals null. Here I can say manum equals this. And I can say classes or scene classes. It's manum dot. Don't know if this will work. Probably not, actually. Let me see if I can even get that reference. Scene class is not defined. Is that? Might have to refresh this. Okay, I guess that did work. Okay, so we just called this on code. see if this works. And that does not work. Config at scene names. I think, wait. Why would that happen? Config at scene names doesn't exist. I guess because that config doesn't exist? Maybe you do actually have to run the code first or something. Or at least do from manum import star? I have no idea if that will work. That will make a difference. Manum is not defined, okay. No, same thing. It still can't do this none type thing. Okay, I won't hunt down where the config gets initialized right now. If I do from manum import star, I thought that would initialize the config. I guess not. And here I import manum. I guess I have to set the config here. For scene name, it's like config at scene names. Isn't it supposed to be figuring this out for me? Something's up here. Module offs.py 77. This is get scenes to render. Okay, so you can make it just return them, I guess. So I'm gonna try passing this full list, I guess. I'll just default that to true. And recompile that. Okay. Okay, so now it does give me something. Even though I can't click on it. Come on. It won't let me save it to a variable, which is annoying. But I should be able to... I think this is supposed to be a list. It's all scene classes. From this, get scene classes from module. Yeah, they should be classes. Where is this used, actually? Scene classes from file. There's a lot of IGUI here. And this is for all of them. Okay, I'm gonna try to get the name from this. Yeah. Okay, so now I have the scene class. If I do this dot underscore name. Oh, that was easy. So I'll do this dot get at underscore name. See if that tells me the name of it. No, and I want to take out that IPDB while I can. Man, this didn't seem to be integer to slice, it's not string. Oh, it's a list. Okay, so I want to do, I guess, dot get at 0 dot get. I think. Yeah, hopefully. I don't know. Proxying these things through... Proxying JavaScript accesses through JavaScript. Python accesses through JavaScript is a challenge. No, not like that. Maybe we can just index it. No, but I don't think so. I can try it. Okay, well, that didn't work either. Okay, that's fine. I've been going for a little over 2 hours, so I'm gonna take a break here. Although I'm probably gonna keep working on either this or maybe some shader stuff. But I gotta take a break first. Alright, it's been a fun stream. And thanks everyone for watching who did.